Okay, let's try this problem. Calculate the percentage of acetic acid molecules ionized in a 0.1 molar acetic acid solution. For acetic acid, the Ka, or acid dissociation constant, is 1.8 times 10 to the minus 5. Okay, we have a Ka. This is an acid. It's a weak acid. So plan of attack, put your acid in water, ice it with a Ka. Let's take our acid, HC2H3O2. We're going to put it in water, allow it to dissociate a little. We get some hydronium ions when H plus is transferred to water, and the acetate ion, C2H3O2 minus. We put it in water. Now we need to go ahead and ice it. The original concentration of my acid is 0.10 molar. Before dissociation, we don't have a lot of H3O plus or acetate in solution, so we're going to call those 0. Then we're going to take away a small bit of this. How much? Well, it doesn't give me a percent ionization. I don't know how much to take away. I know it's not 100% because it's not a strong acid. So all I'm going to do is take away a little, minus X, plus X, plus X. Now let's look at our equilibrium values. At equilibrium, the acetate will be X, hydronium will be X, and since the Ka is relatively small, 1.8 times 10 to the minus 5, 100 times this is smaller than my beginning concentration. I'm going to drop the X term with the rule of 100, and I get 0.10. I'm going to ice it with a Ka. We're going to use the Ka term 1.8 times 10 to the minus 5 and put it into this expression. The Ka is going to be equal to the hydronium concentration multiplied by the acetate concentration, C2H3O2 minus, all over the original acetic acid concentration, HC2H3O2 minus. We'll use the equilibrium value. The Ka for this right now is 1.8 times 10 to the negative 5. That equals on top X times X, or X squared, all over 0.10. Now we have to go ahead and solve for our X. If you go ahead, multiply both sides by 0.1, take your square root, you get an X term of 0.0013 molar. So only a tiny, tiny little fraction of my 0.1 molar actually came off right here, off of the acetic acid. We want to know what percentage is 0.0013 compared to the 0.10 molar solution. So in order for us to get a percentage, we're going to go ahead and take the amount that broke off, or the H plus at equilibrium, 0.0013 molar. We're going to divide that by the original concentration of 0.10 molar, multiply by 100. So 0.0013 divided by 0.10 should give us a percentage of 1.3%, which is very typical of a weak acid. So I hope that helps. Good luck.